Hi guys, in this video we'll do an example related to t-test. Now let us read the question. The following figures refer to the observation in live independent samples. So in this table we are given two samples, sample 1 and sample 2. Sample 1 has following 10 datas and sample 2 has following 10 datas. We have to analyze whether the samples have been drawn from the population of equal means, and we are given t at 5% level of significance for 8 degree of freedom is 2.1, and we have to test whether the means of two population, that is population of sample 1 and sample 2, are same at 5% level or not, and t at 0.05 is 2.0739, that is given in the question. Now we will begin this question by calculating sample variance of sample 1 and 2. So first we will calculate sample variance for sample number 1. And in each and every sample we have total 10 number of datas. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So for sample 1 we will first calculate sample variance. So we will write total datas of sample 1 25, 30, 28, 34, 24, 20, 13, 32, 22 and finally 38. Then after we will calculate x1 minus x1 bar. Now x1 bar is mean value for sample 1. So we will sum up all these datas and we will divide by total number of datas to get x1 bar. So first we will take sum of all the datas. So we will sum up the values of this column and you will get 266. Now in order to calculate sample mean for sample 1, we will write this sum sigma x1 and we will divide by total number of datas in sample 1. So 266 divided by 10. So it will be 26.6. This is mean value for sample number 1. Now after getting this value, we will subtract this value, that is x1 bar, from this x1, all these values of x1. So here 25 minus 26.6. So it will be negative 1.6. 30 minus 26.6. So it will be 3.4. So likewise I have calculated this entire column. This is minus 2.6, negative 6.6, negative 13.6, 5.4, 4.6 and 11.4. Now after getting this, we will take square of this column. So x1 minus x1 bar whole square. So square of minus 1.66, 2.56, square of 3.4 is 11.56, so on and so forth. I will write entire column. One 184.96, 29.16, 21.16, 129.96. Now you have to take sum of all these values. So you will get sigma x1 minus x1 bar whole square is equal to 486.4. Now from this value we will be able to determine variance of sample 1. So it is S1 square. S1 square is variance of sample 1 is equal to x1 minus, this is standard formula, divided by n1. So 486.4 N1 is 10, total 10 datas. So you will get S1 square is equal to 48.64. Now we will follow similar procedure for sample 2. Now I think this is similar procedure. So for sample 2, if you follow similar procedure and you write table for sample 2, x2 minus x2 bar, x2 minus x2 bar whole square. So first you have to put all these datas of sample 2 in this column. Then you have to take sum of all this data in order to get sigma x2. So you will get your sum as 293, and after this you can calculate mean value for x2. It is 293 divided by total number of datas, it is 10, so 29.3. Then using this data you can calculate second column. You have to divide these all x2 values minus this mean value, so you will get this entire column, and you have to take square of all these values in order to get third column. Then you can calculate, if you sum all these values you will get sigma x2 minus x2 bar whole square is equal to 630.08. Now we will calculate sample variance for sample 2, that is sigma x2 minus x2 bar whole square divided by n2. n2 is 10, total 10 number of datas, so 630.08 divided by 10, so s2 square will be 63.008. Now after calculating these all values, let me summarize important values, that is mean value for sample 1, mean value for sample 2, variance for sample 1 and variance for sample 2. Mean value for sample 1 is 26.6, sample 2 is 29.3, 48.64 and 63.008. Now we will use these data to proceed further. Now we will do this example in total 6 number of steps. First step is null hypothesis. H0, which says that two population mean are equal. So it is, there is no significant difference between population means of samples. You have to write the sentence like there is no significant difference between population mean of the samples. You have to write this sentence. After this you have to write alternate hypothesis. Alternate hypothesis, that is H1. It is opposite of this statement. That is, there is significant difference between mean values of two samples. And in the bracket you have to write two-tailed test. This is fixed. You have to write this by default in your answer sheet. You don't have to change anything in these two sentences. Then we'll in this third sentence we will assume something. Level of significance. Level of significance. We will assume level of significance at 0.05. But in fact, in this example, it is already given. Level of significance, that is 5%. So there it is given in the question. But if not given, we will assume as alpha is equal to 0.05. After doing this, we will proceed to step number 4. That is test statistic. And in this test, we will remember this formula for t value, that is difference of mean values of two samples divided by square root sum of variances of two samples, that is s1 square plus s2 square divided by n minus 1. N is equal to 10, total 10 number of data, n is equal to 10. Now you have to put all these values that we had calculated in this equation, and you will get value of t is equal to, let me write here, value of t is equal to 2.0739, sorry, it is 0.7666. If you put all these values in this equation and n is equal to 10, you will get t is equal to 0.7666. Now we will write our final step, that is comparison of two t values. So in final step, that is decision step, decision. So since now guys, if you calculate t value, then you will get in negative, but you have to take always positive value, so you have to write mod here. So since mod t is less than t at 0.05, now t at 0.05 is 2 point, that is given in the question, 2.0739. This value is less than this value. So since mod t is less than t.05, there is no, then we will assume that null hypothesis is accepted. So we have to write, since this, the null hypothesis is accepted, and therefore there is no significant difference in population means of the samples. There is no significant difference in population means of the samples. Therefore, so in question it was also asked that test whether the means of two population are same at 5% level. So we will write, therefore two samples have been drawn from the population of equal means. So we have to analyze whether the samples have been drawn from the population of equal means or not. So in order to answer this question, we will write, therefore two samples have been drawn from the population of equal means. So guys, this is end of our video. I hope you like this video. So please like, share and subscribe, and always thanks for watching.